Module 7.1, Trig function values and right triangles. This is sections 5.3 and 5.4 in your book. 7.1 opener. In this section, we're going to continue the study of trig functions and their relationships to triangles. We're going to go in depth on how to deal with more problematic angles, and finally, we're going to look at some applications. We're going to define the trig functions again, but it's really still going to be the same definition. It just looks a little different. Make sure you understand the definition for reference angles. That's usually the type of triangles or angles you're going to be working with. And always try to make sure you draw a picture so you know which quadrant you're in. Always draw a picture. Right triangle definition of trig functions. Again, we're going to consider an angle in standard position. So we have, let's say, starts on the x-axis, and we're looking at this angle right here. Right? Remember, that means that the terminal side is on the x-axis, and then it moves some certain amount. And we're going to form the triangle just like we did before. Now, instead of talking about this coordinate x and y here, we're going to talk about this length as y and this length is x. Okay, and we're going to call that y side the opposite side. Opposite to what? Opposite to the angle. So let's say this angle is theta. Then when we say opposite, we mean opposite of the angle. And then we're going to call this x side here the adjacent side. Adjacent to what? Adjacent to the angle, right next to the angle. So if we have a triangle, let's say it looks something like this, where our right angle is on this side, and we're talking about this theta here. The side opposite of that theta would be this side. The side adjacent to that theta would be this side adjacent. And the side opposite of the right angle, that's usually called the hypotenuse. Right, the hypotenuse. Hypotenuse. This is what we were calling R before. And we're going to have a couple new definitions, but they're still really the same. We have sine theta is equal to opposite over hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Still y over x, right? Still the same thing. This is still y over r, x over r, y over x. And cosecant, etc. is defined likewise. The main reason we're going to have this new definition is so that we can talk about any sine, cosine, and tangent values of different angles, right? So even if we have a triangle that is not on the x and y axis, but if we have a triangle that looks like this and we know this angle is 34 degrees, we want to be able to talk about what sine of 34 is. We know it's the opposite side of this right here over the hypotenuse. Right? Even if we don't know the x and y coordinates up here, right? Even if it's not on the x and y axis. Cofunctions. For any acute angle A, sine of A is equal to cosine of 90 minus A. As an example, sine of, remember A has to be an acute angle, so sine of, for example, 35 degrees has to equal cosine of 90 minus 35 degrees. In other words, it has to equal, it's 90 minus 30, 60 minus 5 more is 55. Sine of 35 has to equal cosine of 55, etc. for all the other angles here. Tangent of 60 has to equal cotangent of 90 minus 60 is 30 degrees. Find the cofunction expression for sine 35, secant 45, and cosine 0. We just did sine 35. Secant 35, secant 45 would be cosecant of 45, because 90 minus 45 is 45. Cosecant of 0 has to equal sine. That's 90 minus 0, sine of 90. Notice all we're saying is that complementary angles have similar trig definitions, or trig values. Right? Sine is equal to cosine if we have complementary angles. Cosine and sine, cosecant, secant, secant, cosecant, tangent, cotangent. Right? So when you think of cofunctions, you should be thinking sine and cosine are related, tangent, cotangent are related, secant, cosecant are related. Special trig values. These are triangles that you should have memorized. If we consider a 60-60-60 triangle, in other words, an angle where a triangle where the angles are the same, so we have the same one dashed line there to represent that the angles are the same. These have to be 60 degrees because the angles have to add up to 180. 60 plus 60 plus 60 plus 60 plus 60 plus 60 equals 180. In any triangle, the angles have to add up to 180. And we're gonna, for the sake of making the calculations easier, we're gonna say that these side lengths are lengths of 2. So what we're gonna do is we're gonna look at half of that triangle. If we look at half that triangle, the side length is still 2. This is now 1. This is 60 still, and this is half of 60 because we split it up, so it's 30. And this is a 90-degree angle now. If we use Pythagorean theorem, we can find this side length right here. What does Pythagorean say that that side length is? You might want to pause and try that. Square root of 3. And now we can use our definition to find sine of 30. Sine of 30 is the opposite over the hypotenuse. So it's 1 over 2. Opposite of 30. Opposite of 30 over the hypotenuse. Sine of 60 is opposite of 60, square root of 3 over 2. Likewise, cosine of 60 is adjacent to 60 over 2. Cosine of 30 is adjacent to 60 over 2. Okay. You should definitely memorize sine 30 and sine of 60. Sine 30, sine 60. And notice that cosine of 60 has to be the same as sine 30. Remember our cofunctions? 30 and 60 are 90, so these are complementary angles. So these values have to be the same. So really you just have to memorize sine 30 and sine 60. And remember that cosine 30 and cosine 60 are the other way around. What does that say about tangent 30? Well, now that you know that sine of 30 is 1/2, you know tangent 30 is sine 30 over cosine 30. Sine 30 over cosine 30. So the 2's cancel and we're left with 1 over the square root of 3. If we rationalize this, we get square root of 3 over 3. So you don't have to memorize the ones for tangent, because you can find them. Likewise, we're going to consider a 45, 45, 90 triangle. In other words, a triangle where we have a 90 degrees and these two angles are equal. If they're equal, that means that they have to be 45 degrees each. Again, because 45 plus 45 plus 90 is the only way we can get 180 with those two being equal. And we're going to say for the sake of calculation that these side lengths are side lengths of 1. Again, take a second to try to figure out what Pythagorean's theorem is going to say about that side length. Right, that's going to equal the square root of 2. Why? 1 squared plus 1 squared has to equal that side square, c squared. In other words, 1 plus 1 has to equal c squared. In other words, c has to equal square root of 2. What does that say about sine 45 and cosine 45? Sine of 45 is opposite over adjacent, 1 over the square root of 2. Cosine 45 is sine of 45 is opposite over hypotenuse. Cosine 45 is adjacent over hypotenuse, which turn out to be the same values. After we rationalize this, after we multiply by the square root of 2 in the top and the bottom, we get square root of 2 over 2. Again, memorize the one for sine, and just remember that cosine 45 is the same. Tangent 45 then has to be sine of 45 over cosine of 45. It's one thing divided by the same thing, so it has to equal 1. Reference angles. Reference angles are very important. A reference angle is just an angle that is acute and is on the terminal side of theta, is made by the terminal side of theta in the x-axis. In other words, if we have an angle like 120 degrees, 120 degrees is not quite all the way to 180, not quite all the way to this other line here. Let's say that's 120. So that we can use our definitions for sine, cosine. We don't want to go ahead and use this triangle here, right? We kind of do, but we don't. We want to make sure we use this angle here. If this is 120, then to get all the way to 180 here, you would need 60 degrees. So our reference angle is 60 degrees. Okay. You should still remember that you're working in quadrant 2 though. Okay, but let's try to work with the values for 60 degrees instead of 120 degrees. Likewise for 200, it's a little bit over 180, so it's down here somewhere. This is 180, this is 270, so it's not quite at 270. So there's our angle of 200. But again, we want to look at the trig definition, so we want to look at this triangle here so that we can work with the trig functions. So if this is 200 and that's 180, that means that extra little bit right there has to be 20 degrees. So to find this y value, that opposite side, the r and the x, we're going to work with this triangle with a reference angle of 20 degrees. What about the reference angle for 670? Right, 670, 360 plus 360 is what? 720. So it's a little under 2 all the way around twice. So there's 360 and there's 720. Right? So we don't want to go all the way around. We want to go to 360, and then let's say 670 is about right there. We want to look at that triangle right there. So we would need to ask ourselves, if this is 670, how much is going to take us to get to 720? 670 to 720. In other words, to complete the full circle. 670 plus 30 is 700. Then plus 20 more, right, would be 720. So 30 plus 20 is 50 degrees. 50 degrees. So our reference angle is 50 degrees. And that's the triangle we're going to work with. But you should still remember we're in quadrant 4. So in other words, this value will be negative. This value here will be positive. Find all values for theta if cosine theta is equal to negative square root of 2 over 2. Already seeing this negative square root of 2 over 2, you should be thinking maybe something like 45 degrees. Remember, because that's when we had square root of 2 over 2. Okay. We need to find the values for theta if cosine theta is negative square root of 2 over 2. In other words, a negative value for cosine means we're going to be in either quadrant 2 or quadrant 3. So our angle needs to look like this. This is the theta we're looking for, or down here somewhere. That needs to be the theta we're looking for. It's the only place where cosine theta is negative. And because cosine theta is square root of 2 over 2, you should be thinking 45 degrees. So you should be working with a reference angle of 45 degrees. 45 degrees. In other words, if this is 180, what's 180 minus 45 degrees? That's 135. If this is 180 here, what's 180 plus 45 degrees? 225. So those are our two angles, 135 and 225. That's the only way we can get cosine theta to be negative square root of 2 over 2. Inverse trig functions. Right, what if we have different values, like not 45 degrees, not 45 degrees, where we could have guessed, right, what the values were? Then we're going to use the inverse sine functions on the calculator. So because sine of theta is equal to x, when we do the inverse of that, sine inverse of x has to equal theta. In other words, sine inverse of x is an angle. Sine inverse is always an angle. Find theta between 0 and 360, where sine theta is equal to 0.967 and secant theta is equal to 1.05. We're going to do the work here first, and then we'll use the calculator. Sine theta is equal to 0.967. To find theta, we need to take the inverse of both sides. Here they cancel because they're inverses, so we get theta is equal to sine inverse of 0.967. And all we have to do now is type that into the calculator. What about secant theta? We have to do a little bit of work here, because the calculator doesn't have secant inverse. There's no secant inverse on the calculator. But secant theta is 1 over cosine theta. So switching these around, we get 1 over 1.05 is equal to cosine theta. And that tells us to find theta, all we have to do is look at cosine inverse of 1 over 1.05. And the calculator does have that as an option. So let's look at that. So notice that right above sine, there's a yellow option that says sine inverse. So we have to do second sine inverse of 0.967. And again, let's go to the mode and make sure we're in degree modes. We are in degree mode. So we're going to use 75.24. 75.24. What about cosine of 1 over 1.05? Second inverse, 1 over 1.05. 17.75 degrees. What if we wanted to convert that to degrees, minutes, and seconds? Remember, we have to go to angle here. Second angle. Degrees, minutes, seconds. 17 degrees, 45 minutes, 10.045 seconds. Remember that when you use sine inverse and cosine inverse, what you're getting out is an angle. Applications of right triangles. To solve a triangle means to find all the lengths and all the angles. It just means to know everything about the triangle. So we're going to solve the right triangle ABC. And this is how it's usually, whoops, draw. This is how things are usually labeled. If we have an angle A, an angle B, and an angle C, and C here is our 90-degree angle, that's why I'm using this as C, just 90 degrees. Then the sides opposite of them are going to be labeled with lowercase letters. So if this is angle A, this has to be side A. If this is angle B, this has to be side B. If this is angle C, this has to be side C in lowercase. That's usually the standard. Okay, so we know that lowercase c is 12 inches. This side length is 12 inches. A is 34. And C is 90. That's all we know. Well, we can already find B, right? Because we know that 34 plus 90 plus B has to equal 180. We know that B is equal to 180 minus 90 minus 34. In other words, B is equal to 180 minus 90, or 90 minus 34. In other words, B is equal to 56 degrees. So that's not too bad. To find side length B, we can use any of this information now. We know, for example, that sine, and it doesn't matter how you choose to do this, you just have to say something that's true. Let's look at, we know that this is 34 degrees now. No, 56 degrees now, sorry. So sine of 56 degrees, in other words, it's opposite over the hypotenuse. In other words, B over 12 is equal to sine of 56. So if we multiply the 12 over, that tells us that 12 times sine of 56 is equal to B. And we know our value now, we just have to plug it into the calculator. Right? We can do the same thing here to find A. We don't even have to use sine of A. We can use cosine of B. Cosine of 56 is the adjacent to cosine, the adjacent to 56. So A over the hypotenuse, which is 12. That tells us that 12 times cosine of 56 has to equal A. And that's it, we're done. We found B, we found A, we found the angle B. We know everything about the angle, about the triangle. Here's another one. Suppose we have a shadow of a tower. So we have some sort of tower. And its shadow. Let's put some spirals on there or something. Alright. The shadow is 76 feet long. When the angle of elevation of the sun is 34 degrees. In other words, as the sun is shining down on it, this angle down here is 34 degrees. Right? And you can measure that if you're a person down here. Right? You can use one of many tools just to measure that angle. And you can measure this shadow length also, right? 76 feet, 34 degrees. How can you find the height of the tower given that information? Well, we can try sine of 34 and see if that would help. Sine of 34 would be h over the hypotenuse, but we don't know the hypotenuse. So instead of using that, we could try trying to figure that out. Hypotenuse. H, the height, over the hypotenuse. But instead of trying to figure that out, let's use this 76 feet. So let's use tangent of 34. Because tangent of 34 is the opposite over the adjacent. So it's h, the height, over the adjacent side, 76. That tells us that to find the height, all we have to do is multiply 76 feet times tangent of 34 degrees. Let's try that real quick. If we multiply 76 times tangent, 76 tangent of 34, we get 51.26 feet. 51.26 feet. All right. So you give this one a try here. Find the values of sine, cosine, and tangent for 35, 45, and 60. All right, so this might have taken you a while, but this is how I want you to do it. So these are very, very, very useful, so you need to have them memorized. Remember, the ones you need to know are sine of 30, sine of 45, and sine of 60. Memorize them in this order. Square root of 1 over 2. We said that was 1/2. Square root of 2 over 2. And square root of 3 over 2. Notice the pattern. Square root of 1, square root of 2, square root of 3. Remember, cosine is a cofunction, so cosine of 30 has to equal this sine of 60. Cosine of 45 has to equal sine of 45. And cosine of 60 has to equal sine of 30. So you don't have to memorize these values, you just have to remember that they're the other way around. And here you don't have to write square root of 1 over 2, you can just write 1 over 2. And then tangent, you don't have to memorize. Tangent of 30 is just sine of 30 over cosine of 30. Remember that the 2's cancel. And you should know how to rationalize this. It's the square root of 3 over 3. Tangent of 45 is square root of 2 over 2 over the square root of 2 over 2, which is 1. Tangent of 60 is sine of 60, square root of 3 over 2, over cosine of 60, or 1/2. The 1/2's cancel, so I'm left with the square root of 3. Alright, you should now be ready to start homework section 7.1.